Hello, Stats 300, and this is Professor Gonzalez. And what I'd like to do is show you the calculator, the statistics calculator on ALEKS. Now, it shows up on, it has shown up on some of our problems, but not all the problems. And so that's something I've been kind of working on for, gosh, maybe the last 4, 5, 6 days, trying to figure out how to make it show up on all the problems. And I looked through the internet and couldn't find any solutions. Called tech support. They said that I can't control that. Eventually I talked to a senior tech advisor that helps develop these classes in Seattle, and he took a couple days and finally he said he could turn it on, but he wasn't sure if it'd be a statistical calculator. Anyhow, he was able to do it. So we do have the statistics calculator, and now of course, you can go to Start My Path, or also under Learn, and that would give you all the different questions in the interactive homework problems, and also just to make sure you remember. I know I sent out emails, but I went back and I extended probably like chapter 5, 6, 7, and 8. They're all extended, so they're all open. You can go back to if you didn't finish them. You need to finish those, and that will give you credit within that chapter, but it'll also give you credit in the ALEKS Pi at the end of the semester, which gives you another 25% of your grade. So that it kind of get double whammy there. So that's a good thing to do. And you click on that, and then you go and work on some of these problems. Okay, so that's the first thing. Next thing is the statistics calculator was showing up on some of our problems in chapter 9 in that regard, in the interactive side. But I noticed on the assignment side, it wasn't showing up over here. So that was kind of bugging me a bit, that if I go over here in the assignment, and then when I looked at the calculator, it did not show up, and I couldn't figure out how to do it. But they did. I took them from research, but the techs were able to get that on all the problems. So we have that now. So now that I have it, I want to make sure you know how to use it, and it is a pain to show because on my iPad I haven't been able to screen record a website while also being able to use Apple Pencil. So now I'm basically using Canvas Studio, but I got to use a mouse to draw. It's such a pain. But at least I can show you the calculator. This is what the calculator looks like. And the way this calculator is set up is that it has some nice features here. If you want the probability of the probability, which is the area, right, given a z-score, and this is z is less than, so that goes with our notion that when we take a look at z tables, it always gives us, the table always gives us area to the left. And that's what this is basically saying right here, is that I want the probability of z is less than, which is to the left. And so you just plug the z-score in there and hit enter, and it gives you, it figures it out. You don't have to look at the chart. It tells you what that area is to the left. Okay. Likewise, there's another nice button right here. Notice this says probability of t, so that's the t student distribution, right? T values. And t values are different than, we talked about this. This was just the last section of chapter, or 8.2, I believe, is when we introduced that. And t values is, it's this close to a normal distribution, but the higher the degrees of freedom, which is basically the more samples you take, the closer this gets to basically a z-score, which is a normal distribution. So anyhow, we've got these degrees of freedom, which is closely associated with the sample size, which helps us adjust for that, the fact that it's not a perfect distribution until you have a high sample size. But anyhow, this chart is set up. You got to be very careful when you're using the chart with t values. This gives you area to the right, and you can see the picture tells you that. So you got to be careful. You got to know. It's always good to look at the picture. Oh, there's going to be the area to the right. Also, another thing is that over here you have the degrees of freedom, which is one less than your sample size, and then up here you have area to the right tail is what this is. So this is like 0.05 is the area to the right. And then you look at that, and that would be 12 degrees of freedom, and it's 1.782 is the area. Is the t value, which would be right here, representing an area to the right of 0.05. Now, how do you do that on the calculator once again tells you, look at, I want the probability given that t-value that's greater than this number, this t-value I'm going to put in. Well, it's greater than because we want the area to the right, just like our chart is saying. Okay. And then the other thing that's nice is that, remember when we have to work backwards? Sometimes we work backwards and we look at in the body of the table, which is the area of the z-score. So we have the area under the curve, and then we look at the z-score that's associated with that. Well, that's what this button does. It gets a little bit complicated because it's left and rights on that, but I'll get into that. Let me first take a look at a z-score. And like I said, this part, I've really been dreading doing this with this particular canvas function because the drawing is just a nightmare. But maybe I'll just use this as my model. Let's just use this so I don't have to draw this again. And let's say we're looking at let's say that this particular z-score right here happened to be 1.85. Okay, 1.85. Now, how do we do this? And that would be giving us this area to the left, right? And so that would give us the area to the left. So we look up 1.85. There's 1.8, and 5 is right here. Right? There's 5. So 1.85 here, and this would just tell us that if you're at a positive z value of 1.85, which is to the right of 0, so you know the area has to be bigger than 50%, 0.5, and it tells us it is quite a bit bigger. It is 0. I'm going to write this again. 9.678. Okay, it's such a lag and such a pain. Anyway, so that's what it is. So that's nice. Okay, now how do you do this on the calculator? Well, you need to put in the value 1.85 and see if it gives us that same area. Go to the calculator. Let's see, can I go to the calculator? No, I can't. I've got to go out of the drawing function. And I go to the calculator. I click on, notice where it says the probability, which is the area to the left of the z-score. So I click on that. I put that z-score in, 1.85, and voila, hit enter. And there is even a more accurate. We had I believe 0.9678. No, this is 0.9678 for 32252. So even more accuracy. Okay. What if? Okay, so let's go back to the table. And so even a tougher problem was when they, instead of saying here's the z-score telling me the area under the curve, or the probability or the proportions, which is the area under the curve. A tougher problem was probably when they said, okay, here's the area, 0.85, which would be 85%, so 0.85% of the data. So this area to the left is 85% of 0.85. The question is, we're going backwards now, so we've got to go area. What is the z-score that goes with that? And so it was tough. The reason why this was tough is we had to go in the body of the chart, and not every number, every value is going to be associated. So we're not going to, we might be in between two numbers, and that's where it kind of gets to be a little bit of a pain. So for instance, if I'm looking for 0.85, 0.85 is where? There's 0.84, 0.486, 0.85. So it's somewhere in between these two. So it'd be 1 point between 3 and 4. So this is somewhat because my chart can't show every little possibility. 1.03. It's bigger than that. So I guess we can do this with it, right? Say that this t-value is in between. Right? So t-value is bigger than 1.03, but it is also less than 1.04. Okay? And so that's where that's kind of a pain because of accuracy. Once again, going from t-scores to area, there's lots of accuracy that way. But going from area back to t-scores, the accuracy is is not as good. Now, how do you do that on the calculator? Well, it's really nice, but there are some challenges. And that's the challenge is understanding how to input, because it's not, I guess, perfectly straightforward. And that just has to do with this whole idea, are you finding the area, are we talking about the area to the left or to the right? And that's where it gets a little bit dicey. So let me see if I can draw a picture here with our distribution. It's going to be, for sure, it's going to be very sketchy. And we're talking about z-scores, so we do know that if you go right down the middle, that's got to be 0. And by the way, knowing that if you're on the right of this and you're measuring the area to the left, that's going to be bigger than 50%, right? And if you're to the left of 0, well, and you're right of 0, you know the z-scores are positive. And if you're on the left of 0, the z-scores are negative. So that can really help you a lot with this. But you're going to have to make some kind of adjustment. Now here's what I'm talking about. So let's take this one right here. Let's take that same problem we had a second ago, and it said, something like this. Wish I had the Apple icon on this. It said, if you had an area of 0.85, what is this z-score going to be? The tricky thing with this is that the notation, what you're going to use is you're going to use, right here. You're going to use this button right here, okay? And the notation, so it's going to be z sub. Now this sub little box here is going to be the area. Now area is always positive. Area is always positive. So that's what you're going to put in the calculator. But the thing, here's the tricky part. The tricky part is that if you want the area to the left of this point, you have to negate the answer. If you're at the same spot right here and you want the area to the right, it'd just be positive. So let me show you what's going to happen here. And you could also kind of pause. Okay, so anyways, we put that z value in, and you have to remember what that looked like. Because you have to go back to it. But it said, what was the area? Area was 0.85. Okay, and when I put that in, I get a negative answer, and this really kind of is a little bit annoying because I can't edit it. Let me try this whole thing again. But remember, here we were right at the half. That's enough. And here we were right here. We just put in, this had an area of 0.85, and we put in this z value, and we end up getting a negative, you can see it, negative 1.0364. And remember, I told you if you're trying to, no, that's 0. If you're trying to find the area to the left, the way this calculator works, this format works, when you have the z sub, if you're trying to find the area to the left, you have to negate it. Well, this is coming out as a negative, so if you negate a negative, you get a positive 1 point, I'm just going to 0.36. Which really makes sense because here's 0, and if I'm to the right of 0, this better be positive. So, really, you could probably figure that out when this calculator came back with a negative, that something's going on. Well, what's going on is you're finding the value to the left. Now, what if we were trying to find the value to the right of this? Okay, let's see. Well, if this is 0.85 on this side, what would this side be? Well, that side would have to be if this is 0.85, I have 85%. then this little bit over here must be 0.15. So that is the same exact point. See this? See this? So this z value right here of 1.036 is the same point. But look at, if I'm saying what's the area to the left of this 1.036 z value? Well, area is 85, or 0.85. But what's the area to the right of 1.036? Well, the area to the right is 0.15. So that's kind of what you have to distinguish. That's the deal. That's what happens. So watch what happens when I put in 0.15 into the same problem. Well, it's going to give me the positive value here. I don't have to negate it. It already is right here. Because once again, when you're using this notation, the z sub notation, when you put in the area right here, if you want the area to the left of that z value, you have to negate the answer. If you want the area to the right, you do not have to. So if I put in a 0.15, I'm going to get a positive 1.036. And watch, and now the whole thing's going to erase again. But 1.036 is what we should get. Let's try it now. So I can click on here, clear. And this time I'm going to put in 0.15. And I'm going to hit enter, and that should give me positive. And it does, positive 1.0364, and so on. So that's how you distinguish if you're finding the area to the right or the area to the left of a point. Once again, if you're finding the area to the left of the point, and this is true for when you're using this sub notation. Sub notation is when you have z, and then there's a little sub, and that's the area. The area is positive, but you got to locate the z-score on the left or right side of 0, depending if you're finding the area to the left or the area to the right. That's where it gets a little bit confusing, and that's where this calculator is not bad. I mean, it's fast, but it you know, you're not going to probably be looking at the z tables with this. You're going to have to draw a picture and kind of figure out, well, you know, am I on the right side of 0 or left side of 0? So is it positive or negative? And so you can make that adjustment, kind of mentally thinking about that. I think that's pretty much it. Let's do a little bit more, because we can also use the calculator for finding these t values for a t distribution. Now I really wish I had a better way to draw here, but let's see if I can do this without getting too crazy. I'm the one that's going to go crazy on this one. Well, no, I take that back. You might be going crazy too. So here's our t distribution, and let's see, how do I want to do this? Here's a t distribution, and let's do this. So here, of course, this is 0. Once again, that t distribution is a lot like a z, except it's not a normal distribution until the sample size, the n-values, get super large. So that's why we have degrees of freedom to make that adjustment. Now I'm going to put this t-value, and I'd like to know what is the area of this tail on the right here. Now once again, with our format, now we're talking about t-value, so we would go over here to this value. So let's see, what's this t-value going to be? Well, the t-value is going to be, let's say, 2.35. 2.35. Well, for me to move around, this is going to erase on me. Awesome. So you're going to maybe have to take a screenshot of that, and yeah, that's the only way I can actually flip to another screen, I believe. Yeah, it won't work. So look at that. Basically what I'm doing is I'm going to put in a t-value of 2.35, and that will give me the area here. Now also the other piece I want is, I'm going to go ahead and say the degrees of freedom. Remember, that is just one value less than our sample size. We don't have anything to go on. You know, we don't have a problem. We're just making this up right now. So the degrees of freedom are 15. All right, go to your chart right there. Come on. Why is it looking funny? Okay, there we go. Yep, still looking funny. Come on, stop being so. There we go. Okay, so now on this particular problem, I said I'm looking for a t value that's in here. I said degrees of freedom of 15. So there's the degrees of freedom, 15. And I want a t value that is 2.35. And here's the problem. There's 2.1, there's 2.6, 2.35 somewhere in between. So 2.35 is somewhere, is when we have an area. 2.35, oh shoot, where was I at? Degrees of freedom 15. 2.35 is going to be something in between these two. So that's where it gets a little bit dicey, because now what is the area of that value to the right? Well, it's something in between 0.01, and I'm going to throw an extra 0 so you can kind of see what I'm talking about. It's somewhere between that and 0.025. So one way to kind of think about it is if you kind of ignore that 0 there. This is like, well, this is 0.010 and this is 0.025. So it's somewhere in between that, like maybe 0.015 or 16 or 17, something in between, because the answer is right in between there, right? Degrees of freedom 15, I said 2.35. Well, 2.35 is bigger than this and smaller than this, so it's somewhere in between those two areas. So I'm saying it's going to be somewhere around 0.015, something in between. The calculator will figure that out for us in a real quick way. Let's go see what it looks like. Let's go back to the calculator. And I'm looking for I'm looking for the probability of a t value that's greater than this. That means to the right, and that's the drawing I made originally. What was that t value? I have it written down. Luckily, it's 2.35. And remember, this is the chart had degrees of freedom, so you have to put that in. We said that was 15 when we made a problem. And then when I hit, now remember, I got that it had to be between 0.010 and 0.025. What is the actual accurate answer? It is 0.016, right? About. Yeah, so it's something in between. And so the calculator gives you a more accurate answer, and that's actually very easy to use. That's very easy to use. When you use the t sub notation, meaning when you're putting in the area under the curve to get your t score or t value, that's where you got to be careful. Once again, if you're trying to find the area to the left of this t value, you're trying to find, I'm sorry, you know the area, but you're trying to find a t value where the area is to the left of that, you're going to have to negate it. And if you're trying to find a t value right here and the area to the right, you do not have to negate it. So that's the tricky part. But once again, if you just input it, draw your picture, and you know if you're on the right or left-hand side of 0, the middle, then you're already going to know if it needs to be adjusted from positive or negative. That's probably one of the easiest ways to do that. Okay, I hope this helped out. I've been really not stressing, but kind of stressing about this, trying to figure out a way to show this to you, and also make sure that you had access to it, because a lot of the problems you would not even have access to that. So I had to call around a lot for that. And then trying to show this to you, it's just a pain to have a screenshot where I can have the internet, use the calculator, get around ALEKS, and then also have some kind of drawing implemented. It just seems like it's hard to get all that together. Anyhow, I hope this helped out, and you guys take care. I hope you're all healthy and COVID-free.